Our next speaker is going to be Margaret Mitchell. Hi, Margaret.
Hi, how are you?
I'm very good. So Margaret is a researcher working on ethical AI, currently focused on the ins and outs of ethics informed artificial intelligence development in tech. She has published over 50 papers on natural language generation, assistive technology, computer vision, and AI ethics, and holds multiple patents in the areas of conservation generation and sentiment classification. And today, she will talk to us about the values in machine learning development. So let me put your screen in the stream, and then we'll let you go on with your talk.
That's good. Everyone can hear me okay? Yeah. Oh, it even says so in this little preview. Cool. And then to see the comments, I can look maybe on the right side of the screen. I would be really happy for people to ask questions as I go. That said, I might get lost in what I'm doing and miss that someone is asking a question. So I'll try my best. Okay, so hello. Thank you for having me. I recently joined Hugging Face to work on things like values in ML development. So I'm going to be here, I guess, a little bit as a wet blanket, but also hopefully providing some useful insights into the development. Okay. So by now, the machine learning development pipeline is relatively familiar to people who work in AI. So first you collect data, then you train and test a model. You can add additional post-processing, such as selecting among a ranked list or applying thresholds and evaluating, in order for the model to output an eventual decision or answer, and people see the output. But before we even begin the process, the data itself encodes a subset of human perspectives. So what people choose to talk about and how they talk about it based on their experience. So the idea that a data set can be unbiased, which is one of these sort of questions that comes up in the data versus model debates, it's actually both can be biased. And saying that a data set can somehow be unbiased misunderstands what a data set is by definition, right? So a data set is not everything and all experience for all of humanity in the world ever, or in the universe ever, right? By definition, it is a slice of all of that. It's a subset, it's a snapshot. So that means that it is biased with respect to everything else in the universe ever, right? It's a very limited subset, specifically collected from the world, with all kinds of skews reflecting the way that people represent themselves, as well as skews in data collection and annotation, and the way that people talk about the world. So we see biases. We see biases like reporting bias, which is selectively sharing only specific kinds of information. Think about how often people announce that they're breathing, for example, right? All these things are happening all the time. We don't describe them. We don't talk about them. They sort of go without saying. And that means we don't see it in the data, right? So if we're to guess how often people breathe based on a web crawl, we would probably get it wrong. And we also see effects like racism and sexism and ableism and nationalism expressed throughout, which reflects just basic human behavior, right? So these biases then have a ripple effect throughout the rest of model development, as the training data itself is the only information that a supervised machine learning model can learn from. Other kinds of human biases are then layered on top of this and injected into model development by the choice of model, the choice of the objective function, how the model is evaluated. These choices persist in the rest of the model lifecycle. So for example, there's the default effect, which is going with whatever is default for the model you're developing and assuming it is appropriate. So this happens in our model architecture choices. Although, you know, these talks about transformers are sort of showing what happens when you move outside of that default effect, which until transformers were largely, you know, sort of recurrent structures. But it's also things like our optimization choices. And then this is even more true in applied product contexts, where it's used in different kinds of contexts. There's a similar effect of anchoring bias, which is sticking with what one is familiar with. So think of what your loss function is, right? We don't tend to think a lot about that unless we're specifically writing a paper on that. Human biases are further injected into any post-processing decisions or a lack of post-processing, right? So just because you don't think about it doesn't mean that something isn't happening. It just means that you are making the choice to have whatever is in there as a bias persist as a bias. And this is also where things like congruence bias comes in, confirmation biases. Both are biases where you tend to pay attention to outcomes that are familiar to you and leave out outcomes that aren't. So that means we need to do additional work in development to think through the ways that the model can affect different people. And this is a place where risk harms analysis is really key. And finally, once a model is deployed, people see the output and begin to act on that output. But it's not the end of the ML lifecycle, right? So as people act on the output in the outlets where the data is collected, so think about content moderation that you see on YouTube, on Facebook, that, you know, the recommendation systems you see in so many of the different apps we use, that creates more data as we interact with those systems. And then that becomes training data for an updated model, basically encoding all of these biases essentially permanently, right? So this creates an echo chamber feedback loop where the model then learns from the data that has already encoded the biases in the first model decisions. And so this can amplify problematic decisions over time. I like to refer to this as bias laundering, where the final model can have all kinds of ethical issues, and it can be difficult to pinpoint the exact sources that cause them. Although it can be hard, it is part and parcel of the model. So really important to actually model and factor in. I like to call this bias laundering also because it allows me to use this GIF. It is one of the only GIFs I had made by myself, and I'm very proud of it. I just read that when women make jokes in talks, it reflects poorly on them. So I guess I'm reflecting poorly to everyone. Apologies. Okay, so the input data set defines what we care about for the model. The default approach to development is to simply use the training data that is available in a specific data set and to evaluate on the evaluation data that is available in that data set. Right? So if critical aspects of the problem space aren't represented in the pipeline, then deploying the model means you are making the value judgment that these aspects should not be represented. So if the data, the training, the post-processing creates models that disproportionately underperform on some populations, you are implicitly making the value judgment that some populations should receive worse performance. Right? So machine learning development isn't value neutral. You can just, for lack of a better word, be ignorant about those values in your development. And what this means is that we have to think critically about values encoded throughout development if our goal is to advance more human-aligned, more ethics-informed kinds of artificial intelligence. So this brings us to the role of ethics in AI and the role of values. So ethics doesn't provide an answer, but rather it provides frameworks for analyzing problems in light of different human values. So some example human values are shown on the right. And these are exactly the values that can be incorporated not only within the development pipeline, but within the development culture more broadly. So having a basic understanding of the major ethical theories will help us in learning how to articulate and justify our decisions. So let's dive a bit more deeply into the ethical theories that can drive the production of AI systems. So broadly speaking, there are four main families of ethics. Meta-ethics and descriptive ethics are concerned with analyses of ethics in and of itself. Normative is concerned with the norms, the standards, the criteria that define principles of ethical behavior. These are what provide the tools for ethical analyses and development. And applied ethics are essentially ethical theories realized in practice. And within ethics-informed development in a technology company, this would correspond to something like the organizational ethics or the organization's principles. One of the key ideas here is that we all have different senses of morality. We have different cultures and religions that prioritize different kinds of values. So, for example, respect and honor for family tends to be relatively underrepresented in Western philosophy. But when we're working within an organization, these values need to be defined at the organization level in order to provide a common ground of values that employees can build off of and base different decisions on. So there's often this question of whose ethics, right? Like, it's so hard to decide. There has to be one, and it has to be one that we all agree on. But that's not right. The question of whose ethics is simply, it's the organization's ethics. And every organization will be different. You can think of this as a business differentiator, or maybe a grad school differentiator, whatever it is. And these ethics, these values can be defined by culling together the values from all different sources, including all the people who have been hired, right? So there is not one good ethics. There's not one way to say this is ethical and this is not. It's all a function of the people there and what the values they prioritize are. All right, I hope that makes sense. So as a vehicle for operationalizing ethics within a larger development pipeline or within an organization, normative ethics in particular provide several different perspectives. So at a high level, these perspectives concern standards of criteria. There are three main theories. I'm probably doing a horrible job. I'm not an ethicist by training, but I've very much tried to learn ethics within AI. So these are things like virtue, consequentialism, deontological ethics. And in the context of ethics-informed organizational processes, we're largely following a deontological ethics that has been informed by virtue ethics and consequentialism. So let's turn again to our pipeline, where we earlier highlighted how different problematic behavior can be propagated and amplified in a model. In the collection of data, this first bit, values of concern include copyright, consent, fair pay, diversity, and the right to something like contestation, the right to say that you don't want to be in the data. Currently, the state of the art on all of this is terrible. So generally, copyright is not a large part of what's taken into account during data development. Consent is largely absent, at least the sort of informed consent that we would want for people whose data is being used for training models. Fair pay, often it's no pay, so that sucks. And we generally fail at diversity, in part because the culture around machine learning looks to get annotations as if the production of annotations is some black box where you throw in what you want annotated and you get it back, ignoring that everything that happens in that process brings with it tons of different biases. And what country this is happening in is really going to affect what kinds of annotations you're going to get. Okay. And then in model training, values of concern include how appropriate different decisions are in light of the foreseeable effects of the model, right? So you have to think about how this will be used in context. Will these people know what a decision threshold is and how to change it based on what they want to do? Usually not. And so it's very critical to think through how these models will be applied in practice. And in post-processing, values include the consideration of trade-offs and aiming towards fairness of outcomes. So we can now further examine what these ethical values mean within this first data stage. And I would say defining values in data collection and annotation is one of the most pressing issues in technology currently. Questions of who owns the data, whether it can be deleted, what sort of profit or benefit can be derived from it all come into play. And I like to call this the data bottleneck. because it's a touch point of information flow from human thought to AI, but it's the source of an incredible amount of issues. So in particular, there is not a way to have something like the most values, right? Or the most ethical thing. There are trade-offs and tensions in all decisions. And so it goes back to the organizations or the individuals, maybe if you're working alone, what your defined values are and what your prioritization is among them. So for example, we may want to release a data set to help with benchmarking and reproducibility, but this comes with the trade-offs of lack of informed consent, perpetuating problematic ideas that are there without consent, and the fact that the data can't realistically be deleted yet. We don't yet have a state of the art where we can remove data. This means details of individuals in the data can not only be shared, but continually amplified and proliferated without their consent, right? There's this sort of misunderstanding that, well, if it's out there, it's already public, so we can use it. The problem is one instance being public and sort of generally difficult to access is different than being spread all over the world to hundreds and thousands of people. These two things are not the same. And so, you know, in the effort to have benchmarking and reproducibility, we're often making the choice to amplify and proliferate problematic content without consent. We may also want to aim for things like inclusion and diversity within our data, representing different people with respect to their different norms. But this comes up against things like exploitation and tokenism and stereotyping. That's when data is collected with a specific goal of diversity by ignoring sort of all the other factors at play. It's not yet clear what the best methods are, but there's still a lot of work to be done in at least doing somewhat better. So I'll give you an example. A couple of years ago, Google was working on face verification phone unlock for the Pixel and hired a vendor because they needed more photos of Black people. So what did the vendors do? They went to a homeless camp in Atlanta and paid people there who were Black $5 for their face to build Google's diverse facial recognition system that, you know, obviously they would make a lot of profit from. So a few issues there. One is equating Black people with homeless people. So that's some sort of disgusting stereotype I don't think I was even aware of, but there you go. Exploiting people, obviously, $5 and without very informed consent. And also tokenism, where you're not looking at how to include this person in light of what their general life is like, their culture, everything else like this, but actually just focusing on who you could quickly get because of this single characteristic. That's tokenism. Right. So one of the key solutions to operationalizing ethical data development means defining values and priorities upfront and constructing data specifically based on the values. So this massively expands what it means to collect and work with data, making data collection itself a detailed and nuanced process with dedicated roles to handle different aspects of data development and corresponding artifacts that allow the values encoded in data selection to be further examined throughout the pipeline and then within final release decisions. So this can be seen as a life cycle for the data as a whole, as it requires continual monitoring and analyses of the effects of the data and updates then based on these analyses. Now we can turn to the details of operational.
If I can just interrupt you 1 second, we have a question that's very relevant on the data, which is, how do we push for adaptation of more ethical data sets, not ImageNet, CC4, Lion, for example, in major conferences?
Yeah, so maybe not obviously. So a lot of researchers have increasingly been paying attention, and a subset of researchers have been publishing papers on this. So Abeba Berhane has done incredible work on this. Jesse Dodge has led some amazing work on this for C4, right? So the fact that these papers are starting to get accepted is a massive step forward in sort of this general understanding. They were largely rejected, 2 years ago. So there's been an increase already in understanding why these things are important, in part because of, the small subset of researchers really crying out for it over and over again, and making it clear via not only papers, but Twitter and blog posts and interviews. And, so this is sort of happening now. The key now is to make sure that reviewing rubric actually cares about this stuff. So when you're reading a paper that talks about model training and model evaluation, you have to know critical aspects of what that data set for training is, what that data set for evaluation is. And if it's too much to include in the paper, you can have it in the appendix, whatever it is. But while we continue to, really celebrate papers that don't discuss the data they're using at all, we're not going to be incentivizing ethical data practices. So reviewing rubric, also awards. I have this idea that you can get an award at a conference for like best evaluation, or like best analysis of input data or something like that. Currently, we have best paper awards, which is pretty underspecified and tends to bias in certain ways. But once we can start breaking this down into what we really want, both in terms of reviewing rubric and awards, then I think we can really get somewhere.
Yeah. Thanks a lot. That makes sense.
Cool. I didn't see the question, so I guess I'm not like in the right chat or whatever, but cool. So the next bit here in this model sort of pipeline is the model training. And that's where values come into play around the appropriateness of the loss function and the model. Okay. So I'm going to talk about this via a case study. I was able to work on coronavirus forecasting, which was, amazing to be able to work on. And we quickly found that there were a mass amount of model-based decisions that could drastically affect people when the model was deployed. So if you're not technical, bear with me. I'm going to try and explain. If you are, this might be just a repeat, but this is very important. So false positives in a coronavirus forecasting model means that hospitals might be over-equipped, expecting a need for more beds and ventilators. But a false negative means that there would be less resources than needed, which could end in death, right? So there are trade-offs in different kinds of errors, but arguably a model that tends towards false positives is preferable to a model that tends towards false negatives. And one of the issues at play is the choice of loss function. So if you take a look at the different kinds of objectives that can be used, which are on the bottom left, they treat positive and negative instances the same way. These are all measured in terms of absolute values, right? And so that means false positive, false negative, these basic ideas are treated as equivalent. And so for the value-aligned goals of the model, this suggests that some additional work may be necessary for the selection of the most suitable model. Perhaps unsurprisingly, trying to bring this forward at Google mostly meant hostility, and it was a terrible experience. Now I'm telling all of you, still important, even if people are mean. Okay, so moving on, we come to the post-processing and final evaluation. And so here too, it's critical to think through different types of outputs and errors in order to select the most suitable metrics to measure model performance. And it's in this stage that concepts like fairness, diversity, and inclusion are really important. Some of these are more developed than others, so let's talk about them a bit. So for those of you who are not deeply familiar with fairness, one of the most basic ways to think about fairness is in terms of a confusion matrix. So what we have here are a 2 by 2 of references, the ground truth, the thing that's actually there, and model predictions, the thing that the model is guessing. When something exists and it's predicted, that's a true positive. When something doesn't exist and it's not predicted, that's a true negative. The error types we really care about when we're talking about fairness are false positives and false negatives. So these falses, right? So if it doesn't exist, but it is predicted, that's a false positive. If it exists and it's not predicted, that's a false negative. But in one case, a false negative may be better than a false positive. And in another case, a false positive might be better than a false negative. So it's very critical to define what kind of fairness you care about as the equality of essentially false negatives across different groups, equality of essentially false positives across different groups. When you have these equalities based on these kinds of errors, this is what we mean when we talk about fairness. So a case where false positives would be better than false negatives is something like privacy in images. So a false positive here, something gets blurred that shouldn't be blurred. That's just sort of usually a bummer. But a false negative could be something that needs to be blurred, not getting blurred. So that's like identity theft. So we clearly have a decision to make in our model development which kind of errors we want to focus on. And by thinking through in context, it's clear that in a situation like this, we want to make sure to minimize false negatives. False negatives can be better than false positives in something like spam filtering. So here in email, that spam is not caught, so you just see it in your inbox. Usually that's just a bit annoying. A false positive email flagged as spam is removed from your inbox. So if it's from a friend or a loved one, or it's a job opportunity, that's a loss, right? But note that the usage in context really, really matters here. So if foreseeable users include those that are easily scammed, leading to a loss of wealth, then false negatives have a greater risk. And model development needs to balance these different populations in determining the optimal models. The current state of the art, nothing. So low-hanging fruit, we can do a lot better. Okay, cool. So finally, people see the output in this process, and it begins again as people interact with this output, and then the biases are further encoded and more deeply ingrained in the model. I'm not sure how I am on time because I started a little early. I can go.
You have time if you.
Yeah,
you can,
so I want to have time for questions. Let's see.
I have questions right now if you want. I can ask. I have a few questions right now.
Yeah. What I'll do is I'll just kind of like wrap this up really quickly, and then we can go to questions.
Perfect. Yeah.
So here's some basic steps forward. And this is sort of what I would like you guys to remember if you take anything from this talk. We need to align considerations of our own values to this larger group that we're working in, these stated values. Thinking through if the technology should exist at all by using this sort of analysis of foreseeable harms and risks by the expected populations, by the people who will be affected by the model, and how it will be used in context. Establishing basic organizational values can be informed by things like virtue ethics, consequentialism, deontological ethics, where things like privacy, fairness, justice, consent, all these things come into play and then can inform, what we prioritize as we develop. Once we start establishing these things as intentional processes throughout the pipeline, requiring artifacts and documentation, we can start to be able to foresee even more potentially problematic outcomes and make more informed decisions on releases. This goes to the question earlier. One of the critical ways to make this move forward is incentivizing ethics-informed development. So this is things like what gets put in review rubric, what kind of awards we get, what sorts of things are rewarded when they're talked about. And one method I've worked on to capture much of this is model cards. A large part of why I joined Hugging Face is because they were trying to come up with ways to scale model cards, and I thought I could help. But it's essentially an artifact to report sort of all of the above. And finally, throughout, the critical, most serious thing that you can do is encourage and reward foresight, thinking through the outcomes with different people in different contexts. And here's what's important to know. Some people are good at this and some people are bad at this. So if you're bad at this, don't say we can't develop AI with foresight. Just accept that maybe some people have a strength in this and you don't, right? I've been corrected that instead of foresight, what's more important is rapid hindsight. No, some people are good at foresight. Let them stop you from having the need for rapid hindsight, right? So this requires placing people in the appropriate roles to make this aspect of development really shine. Okay, thank you. I'm done. I appreciate it.
Thanks a lot for your talk, Meg. It was very insightful. So I have a few questions that were asked on the forum. Let me pick the first one. So how do we protect ourselves against machine learning system designed primarily without ethics in mind? Because there are obviously algorithms being run out in the world right now. And yeah.
Yeah, I mean, this is a really hard thing to answer. I previously thought that part of the solution was to make sure that the development that has already taken place is retrofitted as much as possible. So taking a look at the kinds of evaluation data sets that were used, the kinds of training data sets that were used, doing more further analysis into what errors it makes, and then essentially fine-tuning, updating the model based on that. Unfortunately, I think in part because of this issue where a lot of people in ML are just not that great at foresight and don't really see the point of it, we're going to need regulation. So that's sort of what I think it comes down to at this point. Yeah.
Makes sense. Another question that was a bit too long, so I'm going to read the last part from the forum. So model transparency seems to be a precondition of the mentioned ethical goals. Dr. Mitchell seems to emphasize the role of input data. Isn't the model's way of decision-making equally important, feature importance, etc., for ethical AI?
Equally important. I would say all of the above is important. I'm not sure how to extract that to numerical values to say that it's equality. But one of the reasons why I do have a focus on transparency is because it's incentivization of good practices throughout, right? So if you have to report how your model does with all these errors, then you're probably not going to release it unless it does well. So as soon as you have transparency, this is a way to essentially incentivize good practices throughout. Input data, I do have a focus on in particular because it's what the model knows. It's the model's knowledge source. So there's so much that can be said about evaluation and all these other things, but the issues very much start with what's in the data. So I would say that's a highest priority. Yeah.
And then speaking of data, what about retraining models that are already trained on unethical data? Is it possible to fix them somehow?
Yeah. So, I mean, by unethical data, I'm taking that to mean, data that has a lack of consent, data that our licenses and copyrights are not being paid attention to, data with PII. So I'll assume that's what you mean by unethical data. I do think it makes a lot of sense to retrain and fine tune. And actually some of the work that I've done has been specifically on bias mitigation techniques and identification of stereotypes and things like this. Whether it's sort of ethical to retrain, I guess that's better than not retraining if it's going to be deployed. So I guess it depends on the context that you're in. if you're writing a thesis, maybe this will become your topic of how to start from scratch. If you're in an organization and you're retrofitting, maybe the best way is to retrain or fine tune a bit. So I think it depends a little bit on context. Yeah, I guess that's the sort of most relevant answer I have to that.
Okay, there are lots of questions about debiasing. Like I have another one here. While training the pre-trained model, is it possible to add a step, including debiasing algorithm? There are emerging algorithms today. Could this make some interesting bias disappear?
Yeah. So there's a lot of work to be done in data that has tended to be not incentivized. There's also a lot of work to be done in models, and this has been more incentivized. And so I just want to make clear, I guess, that one of the cool tricks is around sort of multitask learning. Bias mitigation techniques that tend to work, reasonably well have to do with predicting a few things at once and then discouraging one thing while encouraging another. So, for example, say that you're trying to predict whether or not someone should get promoted. At the same time, you can predict gender. And if you find that the promotion decision is predictable via the gender, then you know that you have a bias system that's biased for gender. So one of the adversarial mitigation techniques that's pretty fun, and there's a couple of papers on this. I wrote one. Alex Butel led a really cool paper on this. Is you essentially invert the gradient. So you predict both, and for everything it's learning about gender, you say the opposite of that. You essentially multiply by -1 and back propagate, right? So that says, like, you don't know what gender is, and you just tell the model until it's essentially random. And that's really a cool way of sort of removing a gender bias. There's other things you can do with like pairing, but a lot of the key techniques are around just this, like having two or more things that you're modeling at once and encouraging one while discouraging another.
That's a very cool technique indeed. Another question, let me scroll a little bit. There might not be a magical solution, but what's the easiest way to determine whether a text generation model is not racist or sexist? And how do we solve this quickly without losing too much of training data?
Solving it quickly, huh?
Well,
yeah, I mean, obviously, as quickly as possible is good if there's sexist and racist things in the world. So, fair enough. So I think that I don't know that it'll ever be possible to have a model that's not sexist or not racist, because I don't know that it's ever possible to have a person who's not sexist or racist, right? I mean, these are all sort of based on heuristics and how our brains work as we're brought up. And so part of, going through like ally training and, these kinds of things means that you have to recognize it and proactively address the kind of patterns that you tend to do. So you would imagine that similarly for a model, you would put in place normative constraints like you do with people. So that means saying that, we are going to mask gender. So there's no distinction between gender when we're training our toxicity model. And so when we have an input gender, we have no way of we don't know what it is, right? And so we won't correlate the two. And toxicity actually particularly has a bias towards the term gay and LGBTQ terms. So there are things you can do like masking those or adding more data. Anywho, the point here is that we can put in place specific normative constraints based on our social knowledge. So this is where social scientists come in, sociologists come in, on how racism and sexism and things like this are expressed. So we can do that, and that's definitely like a quick fix. But a full-on fix might not be possible. But do as much as you can, definitely.
Another question around the bias in data is how could we balance the filtering of bias between freedom of speech and offensive biased consent?
Oh, that's such a good question. Yeah, I've been struggling with this because ideally we can ground AI development in like fundamental rights or human rights. But if you are American centric, then freedom of speech is like, you consider that like a fundamental right, right? But like in other places, privacy is nice, or like you can imagine freedom from discrimination as to be a cool thing, or perhaps a basic right that people should have. But that, you know, comes in conflict with the free speech thing. So, I mean, I think part of the issue here is that when you say free speech, there tends to be an assumption that there is some sort of uniform sampling over all data instances, so that free speech as a whole is reflected. So you have like people talking about women positively and people talking about women negatively, and so it's all free speech. We want it all. But what in fact happens is that the data sets tend to be heavily biased towards men, and using sources where there's misogyny, so like Reddit. And that is not counteracted by free speech about women being awesome or whatever. So yeah, I mean, like one of the things about free speech that is kind of fun to do is actually data collection. So I was part of a project called Project Respect that went to like gay pride parades and had people say like really proud things about their identity and their their LGBTQ like associations and stuff like that. And that created like tons of data that we can use in training a toxicity model. That's a lot of work, and you have to have willing participants and hopefully compensate them whatever they should be paid. But yeah, I mean, there's a few things you can do, but keep in mind that the free speech idea is a little bit hampered by the fact that the free speech that we collect is biased and tends to be more misogynistic and racist than maybe a larger sample would have.
Yeah, definitely. And around like the compensating participant for creating the data, I have another question, which is making it mandatory and forcing to create data sets where each participant is highly paid going to put a lot of pressure on researchers from low resource institutions and researchers from low resources countries? Yeah,
that's a really good question. I think this is where things like governments start to play a role. And I think it's also kind of important to note that this also is very destructive to private companies that are that have, you know, a lot of money. So it's sort of like, I sort of feel like the larger the organization, the more this will hurt them, right? So if for example, you require Google to pay everyone for the data they're producing, Google's business model would be basically destroyed. So, you know, in some ways, we might think of methods where different compensation tiers, you know, make sense for different kinds of organizations. You could get this via regulation. So, you know, if you're a grad student paying, you know, a minimum wage or whatever for your annotations, that's pretty reasonable. That's pretty normal. If you're, you know, a multi-billion-dollar corporation, perhaps paying a lot more is worthwhile, especially because like you're making profit off of this. So it should be a percentage of that profit in some way. So I think there are ways not to over disadvantage low resource groups or organizations. And I think that it could go the other way, like very much harming larger private companies.
And one last question, which is a bit more personal, is what does the regular day-to-day work look like for you?
Oh, well, so I just joined Hugging Face full-time on November 1st. And before that, I was doing like a lot of contracting and consulting. And so I've just been sort of all over the place. I'm someone who wears many hats. Like I like talking about philosophy, and then I like talking about statistics, and then I like coding, and then I like writing. And so I really don't think I have a traditional day. I will say that I hate waking up before 9 a.m. Pacific time. And so presenting at 9:30 was a feat. I hope I seemed coherent. I think that's basically the only standard throughout my day. The only common thing is that I try and not get up until 9. But other than that, yeah, I jump around between coding and thinking through math stuff and writing papers and reading papers and sometimes answering email. Sometimes. Yeah.
Sometimes. Well, thanks a lot for your time this morning, because this was a super interesting talk and very insightful answers to all the questions.
Awesome. Thank you, guys.